Imagine standing at the edge of an ancient lake, its waters unnaturally still. The air hangs heavy with the scent of ash and distant fire. The horizon glows an unnatural red, though the sun vanished hours ago. You are not in some post-apocalyptic future. You are witnessing Earth as it existed 12,000 years ago, when humanity almost ceased to exist. The stars above are unfamiliar. Constellations shifted from their current positions. The moon appears larger, hanging impossibly close. Wildlife that should seem familiar now appears monstrous in scale and proportion. This is not fiction. This is not fantasy. This is our collective past, a chapter of human history that conventional archaeology has either overlooked, misinterpreted, or deliberately ignored for over a century. For decades, mainstream science told us a comfortable story. The transition from the last ice age was gradual. Early humans slowly adapted. Civilizations arose through incremental progress. Nothing dramatic happened. But what if everything we thought we knew about our ancient past was fundamentally wrong? What if our ancestors faced a cataclysm so devastating that it nearly extinguished all human life? The evidence has been there all along, buried in ice cores, hidden in geological anomalies, preserved in ancient myths spanning every continent, and encoded in astronomical alignments that defy conventional explanation. Tonight we will examine this evidence together. We will travel across 6 continents, dive beneath ancient oceans, and extract secrets from polar ice caps to reconstruct the truth about what happened 12,000 years ago. Recent discoveries have forced even skeptical scientists to reconsider long-held beliefs about our past. From nano-diamonds in Greenland ice to mysterious platinum deposits spanning North America, the physical evidence can no longer be ignored. Indigenous stories once dismissed as primitive myths are now being recognized as sophisticated oral histories. Preserving accurate accounts of astronomical events and environmental changes that occurred at precisely this critical moment. The cataclysm wasn't merely environmental, it was cosmic. The night sky our ancestors witnessed became alive with terror as something entered our solar system and forever changed Earth's trajectory. Within a single human lifetime, perhaps within a single day, Earth's climate was thrown into chaos. Sea levels rose hundreds of feet. Advanced cultures were erased, entire species vanished overnight. Yet somehow, against impossible odds, humanity survived. More than survived, some groups appear to have preserved advanced knowledge through this bottleneck event, emerging with mathematical and astronomical understanding that shouldn't have been possible. This knowledge wasn't random, it wasn't accidental. It was focused specifically on tracking celestial cycles and predicting future cosmic events. As if our ancestors were desperately trying to warn us about something they knew would return. Tonight's investigation involves 3 converging lines of evidence that conventional historians have kept separate: geological findings, archaeological anomalies, and astronomical cycles that appear encoded in ancient monuments worldwide. When examined in isolation, each mystery seems merely curious. When connected, they reveal something profound and deeply unsettling about both our past and our future. The implications challenge not just history, but our understanding of human civilization itself. Where did we come from? How advanced were our ancestors? And most importantly, what did they know that we have forgotten? We'll examine controversial archaeological sites that suggest sophisticated human cultures existed thousands of years earlier than officially recognized. Cultures with advanced understanding of mathematics, astronomy, and engineering. We'll analyze ancient texts and mythologies that describe, with disturbing consistency, celestial events and global catastrophes occurring at precisely the time period in question. And finally, we'll confront the most troubling question. If this cosmic cycle that nearly ended humanity 12,000 years ago is real, could it happen again? Could we be approaching another such moment? This investigation requires patience. The evidence builds gradually, like pieces of a vast puzzle. Some connections will seem speculative at first, only to be reinforced by subsequent discoveries. I ask only that you withhold judgment until all evidence has been presented. The conclusions may challenge your worldview, but the journey itself will transform how you perceive human history. By the end, you'll understand why certain ancient cultures became obsessed with tracking celestial cycles, why megalithic structures worldwide align with astronomical events, why indigenous stories so consistently describe fire from the sky. Our journey begins where conventional history claims civilization itself began, in the fertile landscapes between the Tigris and Euphrates rivers in what is now Iraq. But we won't stay there long. The true origins of this story lie much earlier and much more globally than conventional archaeologists have been willing to acknowledge. 12,000 years ago, approximately 10,000 BC, something catastrophic happened to our planet. The evidence appears in ice cores, geological records, and archaeological sites across every continent. Within a geologically instantaneous time frame, perhaps even a single day, Earth's climate was thrown into chaos. Global temperatures fluctuated wildly, entire ecosystems collapsed, sea levels rose dramatically as ice sheets melted. Scientists call this period the Younger Dryas, named after an Arctic flower that suddenly reappeared in European pollen samples, indicating a rapid return to Ice Age conditions after warming had begun. What makes the Younger Dryas so puzzling is its suddenness. Earth had been emerging from the last Ice Age, warming gradually, when temperatures abruptly plummeted back to Ice Age conditions, then just as abruptly warmed again centuries later. Conventional explanations have suggested melting ice sheets disrupted ocean currents, but this theory fails to account for the global nature of the event or the extraordinary speed of its onset. More troubling are the extinction patterns. North America lost 35 genera of large mammals virtually overnight, including mammoths, mastodons, giant ground sloths, and saber-toothed cats. This represents one of the most dramatic extinction events in Earth's history. Similar mass extinctions occurred simultaneously on other continents. Whatever happened wasn't localized. It was global in scale and catastrophic in impact. The timing correlates precisely with another anomaly: the disappearance of the Clovis people, North America's earliest well-documented human culture. Their distinctive tools and settlements vanish from the archaeological record exactly as the Younger Dryas begins. But the stakes extend far beyond rewriting history books. If what happened 12,000 years ago was not a random event, but part of a cosmic cycle, one potentially tied to our solar system's movement through the galaxy, then understanding it becomes crucial, because such cycles repeat. The controversial Younger Dryas impact hypothesis proposes that a fragmented comet or asteroid struck or exploded above North America, causing continental wildfires, climate disruption, and mass extinctions. Initially dismissed by mainstream archaeologists, this hypothesis has gained credibility. As researchers discover more physical evidence, including nanodiamonds, magnetic spherules, and platinum anomalies in geological layers dating precisely to this period. These materials form only under conditions of extreme heat and pressure, consistent with cosmic impacts, not gradual climate change. They appear in a distinct layer that scientists call the black mat. Visible at archaeological sites across North America, similar evidence now appears in geological samples from South America, Europe, and Asia, suggesting not a localized impact, but multiple airburst events across the hemisphere. A cosmic shotgun rather than a single bullet. The human toll would have been unimaginable. Wildfires would have raged across continents. Dust and soot would have blocked sunlight for years. Acid rain would have poisoned water sources. Surviving humans would have faced starvation, exposure, and social collapse. Yet remarkably, some groups did survive. More than survive, they preserved sophisticated knowledge through this bottleneck event. Knowledge that appears encoded in the earliest monumental structures that emerged after the catastrophe. Consider Göbekli Tepe in Turkey, a sophisticated complex of massive stone pillars precisely aligned to astronomical events and covered in carvings of animals. Conventional archaeology dates it to approximately 9600 BC. Immediately after the Younger Dryas event, its builders possessed engineering knowledge that shouldn't have existed for thousands more years. The site's astronomical alignments suggest its primary purpose was tracking celestial movements, as if monitoring the sky for signs of returning danger. Similar obsessions with astronomical observation appear in early cultures worldwide following this period. From Stonehenge to the pyramids, from Mayan observatories to Polynesian navigation systems, our ancestors seemed fixated on watching the skies. If the Younger Dryas catastrophe was triggered by a cosmic event, one potentially recurring on a predictable cycle, then these ancient astronomical observatories take on new significance. They weren't merely calendars, they were warning systems. The stakes of our investigation thus extend beyond academic curiosity. If we've misunderstood our past, we may be blind to dangers in our future. Ancient knowledge dismissed as primitive mythology might contain crucial warnings. Modern civilization exists in a state of profound vulnerability. Our interconnected systems, concentrated urban populations, and just-in-time supply chains leave us more susceptible to collapse than our ancestors were. A cosmic event similar to what occurred 12,000 years ago striking Earth today would cause unprecedented humanitarian catastrophe, potentially ending technological civilization and reducing survivors to pre-industrial conditions within days. Yet we spend more on coffee annually than on detecting and tracking near-Earth objects. Our planetary defense systems remain rudimentary. We've identified only a fraction of potentially hazardous objects in our solar system. More troubling is the possibility that the Younger Dryas event wasn't random. Some researchers suggest it corresponds to cyclic movements of our solar system through the galactic plane, a journey that brings us through regions of increased cosmic debris approximately every 12,000 years. If true, we may be approaching another such crossing. The knowledge our ancestors tried to preserve through monumental architecture and astronomical alignments may become relevant with new urgency. Understanding what happened 12,000 years ago isn't merely academic. It could be essential for anticipating what might happen in our near future. The warning signs, if they exist, would be astronomical in nature. Chapter 3. Historical context. To understand the world of 12,000 years ago, we must first reset our mental timeline. Conventional history tells us civilization began around 5,000 years ago in Mesopotamia with the emergence of writing, agriculture, and cities. This narrative, comfortable and familiar, places everything before that threshold in the realm of prehistory, a primitive time of hunter-gatherers with simple tools and simpler beliefs. But this view is increasingly untenable. The world of 10,000 BC was emerging from the grip of the last ice age. Vast ice sheets that once covered North America and Northern Europe were retreating. Sea levels were rising, inundating coastal regions that had been dry land for millennia. Humans had already colonized every continent except Antarctica. They had developed sophisticated tools, artistic traditions, and complex social structures. The transition to agriculture had begun in multiple locations independently. Genetic studies reveal our species had already experienced a significant bottleneck event, a dramatic reduction in population, sometime between 70,000 and 30,000 years ago. Our global population likely numbered only a few million individuals by 10,000 BC. These humans were physically identical to us in every way. Their brains were the same size as modern humans. They possessed the same capacity for language, abstract thought, technological innovation, and social organization. The popular conception of cavemen as brutish and primitive is contradicted by archaeological evidence. The cave paintings at Lascaux and Chauvet in France demonstrate sophisticated artistic techniques, including perspective, shadowing, and mixed pigments. These weren't simplistic stick figures, but masterful artistic expressions created by people with deep observational skills and cultural traditions. Many contain astronomical references and track lunar phases, suggesting mathematical knowledge we've overlooked. By 10,000 BC, humans had developed boats capable of open-water navigation. They had domesticated dogs from wolves. They created musical instruments, wove textiles, and crafted pottery. They conducted trade over vast distances, exchanging materials and likely ideas. Perhaps most significantly, they observed and recorded celestial events with remarkable precision. The sophistication of these astronomical observations contradicts our assumptions about primitive cultures. The people of this era lived through dramatic climate changes. Within living memory, Vast ice sheets had covered much of the northern hemisphere. As these melted, sea levels rose, coastal regions flooded, and environments transformed rapidly. Adapting to these changes required intelligence, cooperation, and innovation, precisely the qualities that define humanity. Our ancestors weren't passive victims of environmental change, but active responders who preserved crucial knowledge through oral traditions. Then something happened that tested human adaptability beyond any previous challenge. The warming trend suddenly and dramatically reversed. Temperatures plunged back to near Ice Age conditions within what might have been a single season. This abrupt climate reversal marks the beginning of the Younger Dryas period, named after an Arctic wildflower whose pollen suddenly reappears in European soil samples from this time, indicating a rapid return to cold conditions. Conventional explanations suggest that melting ice sheets disrupted Atlantic Ocean currents, particularly the Gulf Stream, causing temperatures to plunge across the northern hemisphere. But this theory struggles to explain several key aspects of the evidence. First, the speed of onset appears too rapid for ocean current disruption alone. Ice core samples from Greenland indicate temperature drops of up to 18 degrees Fahrenheit within decades, possibly even faster, as ice cores provide minimum timeframes. Second, the evidence shows simultaneous environmental changes across both hemispheres, difficult to explain through North Atlantic Ocean current disruption alone. Something global appears to have occurred. Third, the Younger Dryas ended just as abruptly as it began, with temperatures warming rapidly around 9600 BC. This pattern of sudden change in both directions defies gradual explanations. In North America, this period coincides precisely with the disappearance of the Clovis culture, identified by their distinctive projectile points found throughout the continent. Their sophisticated tool-making tradition vanishes completely from the archaeological record. Simultaneously, 35 genera of large mammals went extinct in North America, including mammoths, mastodons, giant sloths, American camels, and the iconic saber-toothed cats. Similar extinction patterns occurred across other continents. The timing is extraordinary. These animals had survived multiple ice ages and interglacial periods over millions of years. Then suddenly, at precisely this moment, they vanish from the fossil record. Human populations also appear to have crashed globally. Genetic studies suggest a significant population bottleneck occurred during this period, further evidence that whatever happened wasn't merely a climate shift, but something far more catastrophic. In the Middle East, curious developments were underway. At Göbekli Tepe in Turkey, someone began constructing a massive complex of stone pillars, each weighing up to 20 tons, arranged in precise astronomical alignments and decorated with carvings of animals. Conventional dating places its construction beginning around 9600 BC, exactly as the Younger Dryas ended. The technical sophistication required to quarry, transport, carve, and erect these monoliths contradicts our understanding of hunter-gatherer capabilities. More puzzling, many animals depicted at Göbekli Tepe were extinct locally by the time of construction. The builders were preserving knowledge of creatures they hadn't personally encountered, another indication of sophisticated cultural transmission through catastrophe. Similar megalithic sites began appearing globally in the millennia following the Younger Dryas. From Stonehenge to Easter Island, from Egyptian pyramids to Mesoamerican observatories, all share a common obsession with astronomical alignment and timekeeping. Chapter 4. First Evidence. Our first concrete evidence comes from Greenland ice cores, cylindrical samples extracted from ancient ice sheets that preserve atmospheric conditions going back tens of thousands of years. These cores contain annual layers, like tree rings, allowing precise dating. When examined at the Younger Dryas boundary, approximately 12,800 years ago, these ice cores reveal something extraordinary, a sudden spike in platinum particles. Platinum is rare in Earth's crust, but common in asteroids and comets. This platinum anomaly appears not just in Greenland, but in geological samples across 4 continents, a global signature suggesting something extraterrestrial interacted with Earth's atmosphere at precisely this time. In the same geological layers, researchers have discovered nanodiamonds, microscopic diamonds that form only under conditions of extreme heat and pressure. These include a rare hexagonal form called lonsdaleite, known as impact diamonds. Lonsdaleite forms when graphite is subjected to the extraordinary pressures and temperatures of a cosmic impact. Their presence in Younger Dryas boundary layers across multiple continents provides compelling evidence for a cosmic event. Adding to this evidence are magnetic spherules, tiny iron-rich spheres that form when molten material is ejected into the atmosphere and rapidly cools. These spherules appear in boundary layers from the Carolinas to California, from Belgium to Syria. In 2019, researchers discovered a massive impact crater beneath Greenland's Hiawatha Glacier. Measuring over 31 kilometers wide, this crater has been provisionally dated to the Younger Dryas period, though precise dating remains challenging. More recently, geochemical analysis of ice cores from this period revealed unusual concentrations of iridium, another element rare in Earth's crust, but common in meteorites. The pattern matches what would be expected from a major cosmic impact event. Perhaps most visually striking is the black mat, a distinctive dark layer of sediment found at archaeological sites across North America, dating precisely to the Younger Dryas boundary. This layer contains high concentrations of charcoal, soot, and magnetic particles. The black mat appears directly above the last known Clovis artifacts and the last appearances of now extinct Megafauna. Whatever created this distinctive layer marked the end of an entire ecological and cultural era in North America. Chemical analysis of this layer reveals high concentrations of nanodiamonds, carbon spherules, and elevated levels of iridium and platinum, a fingerprint consistent with material ejected during a cosmic impact event. At multiple sites, researchers have discovered melted geological materials requiring temperatures exceeding 2,200 degrees Celsius. Impossibly hot for wildfires, but consistent with the thermal effects of a major cosmic impact or airburst. These temperatures are sufficient to melt quartz, one of Earth's most heat-resistant minerals. Samples of melted quartz, called melt glass, have been found at Younger Dryas boundary sites from Pennsylvania to Syria. The geographical distribution of these materials suggests not a single impact, but multiple airbursts across the hemisphere, consistent with the fragmentation of a large comet as it entered Earth's atmosphere. Such an event would have produced devastating wildfires, as superheated air ignited forests and grasslands across continents. Indeed, the geological record shows unprecedented levels of charcoal and soot in boundary samples worldwide. These wildfires would have injected massive amounts of soot and dust into the atmosphere, blocking sunlight and triggering rapid cooling, precisely what the ice core records show happened at the onset of the Younger Dryas. The cosmic origin of the Younger Dryas becomes more compelling when we examine ancient accounts. Indigenous cultures across the world preserve stories of fire descending from the sky, followed by a long winter and devastating floods. From the Ojibwa legends of Nanabojo to the Greek myth of Phaeton, from Hopi stories of previous world endings to Aboriginal Australian traditions of Dreamtime catastrophes, these narratives share remarkable similarities despite developing in isolation. These weren't merely imaginative tales, but sophisticated oral records preserving actual observations. When stripped of their cultural embellishments, they describe a consistent sequence: fiery objects in the sky, global conflagration, climate collapse, and flooding. The timing aligns with geological evidence. Many traditions place these events after the retreat of the ice, but before the establishment of agriculture, precisely the Younger Dryas time frame. Ancient symbolic systems also preserve this knowledge. The curious recurrence of the constellation Draco, the celestial dragon or serpent, in early astronomical traditions worldwide, may reference the comet that fragmented in Earth's atmosphere. Comets were universally described as serpentine or dragon-like entities in ancient cultures, their long tails resembling a serpent's body. Their unpredictable appearances made them harbingers of doom in virtually every ancient astronomical tradition. But perhaps most compelling is what emerged after the catastrophe. As the Younger Dryas ended around 9600 BC, we see the simultaneous appearance of megalithic architecture with sophisticated astronomical alignments across multiple continents. At Göbekli Tepe in Turkey, massive T-shaped pillars weighing up to 20 tons were arranged in precise circular patterns aligned to track celestial movements. Carbon dating places, construction beginning immediately after the Younger Dryas period ended. On Pillar 43 at Göbekli Tepe, researchers have identified what appears to be a pictorial representation of the cosmic event itself, with symbols representing the Sun, Taurus constellation, and what may be the fragmented comet. The date encoded in this astronomical imagery, approximately 10,950 BC, precisely matching the onset of the Younger Dryas according to ice core chronologies. The builders weren't just commemorating history, they were recording an astronomical date. This obsession with precise celestial observation appears simultaneously in post-Younger Dryas cultures worldwide, from Nabta Playa in Egypt to ancient sites in Peru, from early Chinese observatories to megalithic structures in Western Europe. These weren't primitive sun worship sites, but sophisticated astronomical computers built in stone, designed to track complex celestial cycles with remarkable precision. Their primary focus appears to be monitoring the same regions of sky associated with the original catastrophe. If the Younger Dryas event was triggered by Earth's passage through a field of comet debris, a journey our planet repeats on predictable cycles, then these ancient observatories take on new significance. They were warning systems. But the most troubling evidence comes from ice core analysis of the Younger Dryas termination. Whatever caused temperatures to plunge also ended with extraordinary abruptness, as if a cosmic switch was thrown, returning Earth to warming conditions. This pattern defies conventional climate change models. Both the onset and termination of the Younger Dryas appear too sudden for gradual processes. Something external to Earth's climate system appears to have intervened, twice. The implications are profound. If the Younger Dryas was triggered by cosmic forces operating on predictable cycles, then understanding these cycles becomes crucial for anticipating future threats. Ancient knowledge preserved in stone and myth may contain vital warnings, and recent astronomical discoveries suggest our solar system does indeed move through regions of increased cosmic debris on predictable timescales, roughly matching the periodicity encoded in ancient monumental structures. Which brings us to the most troubling question: where are we now in this cycle? If the Younger Dryas catastrophe occurred approximately 12,800 years ago, and these cosmic cycles operate on roughly 12,000-year intervals, simple mathematics becomes unsettling. Are we approaching another such crossing? Have we dismissed as mere superstition the very warnings our ancestors worked so diligently to preserve in stone, symbol, and story? The evidence suggests we may have tragically misunderstood their message. Chapter 5. Contradictions and Anomalies. As compelling as the cosmic impact hypothesis appears, it faces significant resistance from established archaeology. This resistance isn't simply scientific skepticism. It reveals deeper contradictions in how we understand human history. The conventional timeline of human civilization begins around 3500 BC with Sumerian cuneiform writing, followed by Egyptian hieroglyphics. Agriculture supposedly began around 10,000 BC in the Fertile Crescent, with cities emerging thousands of years later. This neat linear progression, from primitive hunter-gatherers to farmers to city builders, forms the foundation of our understanding of human development. But what if this timeline is fundamentally flawed? Consider Göbekli Tepe again. Conventional dating places its construction beginning around 9600 BC, immediately following the Younger Dryas period. This site features massive stone pillars arranged in sophisticated circular patterns with precise astronomical alignments. Each pillar weighs between 10 to 20 tons. They're covered in detailed carvings of animals, many showing anatomical knowledge possible only through close observation. The engineering required to quarry, transport, and erect these monuments contradicts our assumptions about primitive societies. More troubling for conventional timelines, Göbekli Tepe was deliberately buried around 8000 BC. Its builders didn't abandon it. They intentionally preserved it under thousands of tons of debris, as if protecting it for future rediscovery. This deliberate burial appears at multiple sites worldwide from this period. The ancient complex at Gunung Padang in Indonesia shows evidence of construction beginning over 20,000 years ago, with strategic modifications and protective burial following the Younger Dryas period. Ground-penetrating radar at Gunung Padang reveals sophisticated chambers and water management systems beneath the visible structure, engineering that shouldn't have existed for another 10,000 years, according to conventional timelines. Similar anomalies appear at Derinkuyu in Turkey, an underground city capable of housing 20,000 people with sophisticated ventilation systems and water management. Though officially dated to 1200 BC, geological evidence suggests much earlier origins. These underground complexes share common features: long-term food storage capabilities, sophisticated air circulation systems, and multiple defensive choke points. They appear designed for long-term survival during surface catastrophes. Were these elaborate underground shelters constructed by people who anticipated another cosmic event? Their sophisticated engineering contradicts our understanding of ancient technological capabilities. Perhaps most puzzling are the numerous underwater structures discovered in recent decades. Off the coast of Japan, the Yonaguni monument features right angles, straight walls, and precise terracing, architectural features that nature rarely produces spontaneously. Similar underwater structures appear off India's Gulf of Cambay, where acoustic imaging reveals geometric patterns consistent with urban layouts. These structures now rest under more than 120 feet of water. Conventional geology tells us these areas were last above water over 12,000 years ago, before cities supposedly existed. Yet these structures show characteristics of intentional design and construction. The contradictions extend to ancient knowledge systems. We've discovered Babylonian clay tablets containing trigonometric calculations more accurate than modern tables developed in the 19th century. How did this mathematical sophistication emerge fully formed? The Antikythera mechanism, an ancient Greek astronomical computer discovered in a 2,000-year-old shipwreck, demonstrates mechanical engineering capabilities supposedly impossible for its time. It tracked planetary movements with astonishing precision. These anomalies challenge our assumptions about linear technological development. They suggest our ancestors possessed sophisticated knowledge that was subsequently lost, consistent with civilizational disruption following catastrophic events. Perhaps most compelling are the contradictions in ancient maps. The Piri Reis map, compiled in 1513 from ancient sources, shows Antarctica's coastline without ice, a geographical feature not verified until modern radar mapping in the 1950s. Antarctica has been ice-covered for at least 12,000 years, according to conventional geology. How did the ancient sources used by Piri Reis know the continent's ice-free coastline? The implications are extraordinary. The anomalies extend to astronomical knowledge. Ancient structures worldwide incorporate precise measurements of Earth's dimensions that require spherical trigonometry and coordinated observations across vast distances. The Great Pyramid incorporates the mathematical value pi in its proportions, encodes the exact circumference of Earth in its base measurements, and aligns with true north more accurately than modern buildings. How was this precision achieved? Even more puzzling, many ancient sites encode the phenomenon of axial precession, Earth's slow 25,920-year wobble that shifts our view of the stars over millennia. Recognizing this cycle requires multi-generational observations and sophisticated record-keeping, yet this knowledge appears in diverse cultures, separated by vast distances, encoded in architecture, mythology, and mathematical systems. How did isolated ancient peoples discover the same complex astronomical cycle independently? Or was this knowledge preserved from an earlier shared source? A sophisticated parent culture that experienced the Younger Dryas catastrophe and dispersed its surviving knowledge keepers globally. This hypothesis, controversial but increasingly supported by evidence, suggests the Younger Dryas event didn't just mark the end of hunter-gatherer cultures, but potentially disrupted an earlier, advanced global civilization. Such speculation was once dismissed as pseudoscience, But recent discoveries force reconsideration. We find identical mathematical constants encoded in monuments across continents. We find common astronomical alignments in structures supposedly built by isolated cultures. We find sophisticated medical knowledge preserved in ancient texts, including anatomical understandings impossible without systematic dissection and documentation. The Sushruta Samhita from ancient India describes surgical techniques requiring specialized tools and empirical knowledge. We find evidence of ancient electrical devices, like the Baghdad battery, a 2,000-year-old galvanic cell capable of generating electrical current. Electroplated artifacts from Egypt suggest practical applications of this knowledge. The conventional explanation that these represent random accidents or unrepeatable innovations becomes increasingly untenable as the pattern of impossible ancient knowledge grows. These contradictions between conventional timelines and physical evidence aren't merely academic curiosities. They suggest our entire understanding of human history may require fundamental revision. If advanced knowledge existed before the Younger Dryas catastrophe, knowledge subsequently preserved in fragments by surviving cultures, then we must reconsider the narrative of steady human progress from primitive to advanced. Perhaps our history is cyclical rather than linear. Perhaps civilization has risen and fallen multiple times, with each collapse erasing most evidence of what came before, leaving only the most durable structures and the most carefully preserved knowledge. This cyclical model aligns with traditions from diverse cultures, from Hindu cosmic cycles to Mayan world ages to Hopi prophecies of previous worlds. These weren't primitive superstitions, but sophisticated historical models preserving memories of actual collapses. The most troubling contradiction may be in how we interpret ancient warnings. Across cultures, we find specific references to celestial threats returning on calculable cycles, encoded in mythology, architecture, and astronomical record-keeping systems. Were our ancestors merely superstitious, obsessively tracking celestial movements for religious reasons? Or were they preserving vital information about cosmic cycles that directly threatened human survival? Chapter 6. Myths and out-of-place evidence. Throughout human history, myths have been dismissed as primitive fantasies, colorful stories created to explain natural phenomena or reinforce social norms. But what if some myths represent something more profound, encoded memories of actual catastrophic events? When we examine global flood myths, striking patterns emerge. Over 200 distinct flood traditions exist worldwide, from the biblical account of Noah to the Mesopotamian epic of Gilgamesh, from Chinese legends of Yu the Great to Mayan accounts of previous world endings. These narratives share specific elements: divine warning, construction of survival vessels, global flooding, and subsequent cultural renewal. Most place these events after the last ice age, but before the emergence of classical civilizations. Comparative analysis reveals these aren't merely copied stories. Indigenous flood myths from isolated regions contain locally specific details while maintaining the same core sequence of events, suggesting independent preservation of a common experience. The Ojibwa tribe of North America preserves the story of Nanabojo, who survived a great flood by floating on a log. The Greek tradition describes Deucalion and Pyrrha surviving in a chest. Australian Aboriginals speak of ancestral beings escaping rising waters. These accounts consistently describe the mechanism of catastrophe: celestial disturbances, followed by fire from the sky, then devastating floods. This sequence matches precisely the geological evidence for the Younger Dryas event. More intriguing are myths describing previous world ages that ended in specific ways. Hopi traditions speak of 3 previous worlds destroyed by fire, ice, and water. Hindu cosmology describes yugas, world ages ending through different catastrophic means. Mesoamerican calendars tracked vast time cycles, with the previous world age allegedly ending in a great deluge. Their timing places this deluge near the end of the last ice age, aligning with geological evidence for rapid sea level rise. These traditions weren't mere stories, but sophisticated astronomical calendars. The Mayan long count calendar tracked a 5,926-year cycle that began around 3114 BC, a date corresponding to approximately 3 precessional months after the Younger Dryas event. The Hindu Kali Yuga, our current world age, allegedly began around 3102 BC, almost identical timing to the Mayan calendar. This synchronicity across isolated cultures suggests they were tracking the same astronomical phenomenon. Perhaps most intriguing are myths describing celestial battles, cosmic dragons or serpents disrupting the world order. The Norse Midgard serpent, the Hindu Vritra, the Mesopotamian Tiamat, the Egyptian Apophis, all represent destructive serpentine forces associated with the sky. These weren't arbitrary symbols, but specific descriptions of cometary encounters. The serpentine appearance of comets with their trailing debris is visually unmistakable. Ancient observers documented actual cosmic events through mythological frameworks. This interpretation gains credibility when we examine physical artifacts. At Göbekli Tepe, Pillar 43, known as the Vulture Stone, appears to depict the constellations and a comet strike occurring around 10,950 BC, precisely when the Younger Dryas began. This astronomical record carved in stone contradicts our assumptions about prehistoric astronomical knowledge. The precise star mapping required sophisticated observational techniques and mathematical understanding supposedly unavailable to hunter-gatherers. Similar astronomical encodings appear in cave paintings throughout Europe. At Lascaux in France, the famous bull imagery aligns with the Taurus constellation as it appeared 17,000 years ago, with clusters of dots representing specific star patterns. These weren't primitive decorations, but precise astronomical records, preserving observations of celestial events across generations. They demonstrate sophisticated knowledge of celestial mechanics thousands of years before the supposed dawn of civilization. Out-of-place artifacts further challenge conventional timelines. The Antikythera mechanism, a 2,000-year-old astronomical computer with differential gearing, demonstrates mechanical engineering supposedly impossible for its era. Examination reveals it tracked not just planetary positions, but eclipse patterns requiring complex mathematics. Its manufacturing precision required specialized tools and theoretical understanding, yet it appears fully developed without obvious evolutionary precursors. Similar anomalies appear in ancient metallurgy. In India, the iron pillar of Delhi has withstood corrosion for over 1,600 years due to its precise phosphorus content, a metallurgical technique only rediscovered in the 20th century. At Mohenjo-Daro in modern Pakistan, archaeologists discovered vitrified streets and fused pottery, suggesting exposure to temperatures exceeding 1,500 degrees Celsius, hotter than any known ancient industrial process, but consistent with extreme thermal exposure. Perhaps most puzzling are ancient electrical artifacts. The Baghdad battery, a 2,000-year-old clay jar containing a copper cylinder and iron rod, generates electrical current when filled with vinegar. Electroplated artifacts suggest practical applications of this knowledge. Ancient texts describe technologies seemingly impossible for their eras. Sanskrit accounts in the Vaimanika Shastra describe flying machines with propulsion systems and navigational instruments. The Egyptian Tali papyrus reports aerial phenomena with specific technical details. Conventional archaeology dismisses these as imaginative fantasies, but similar accounts appear across isolated cultures, with technical details suggesting observation rather than invention. Ancient architectural knowledge presents similar anomalies. Structures worldwide incorporate advanced mathematical concepts like the golden ratio, precise astronomical alignments, and acoustic properties that enhance specific sound frequencies. The massive stone blocks at Baalbek, Lebanon, some weighing over 800 tons, were quarried, transported, and precisely positioned using unknown techniques. Modern engineering struggles to explain how these feats were accomplished with ancient technology. Similar megalithic precision appears at Machu Picchu, where stone blocks fit so perfectly that not even a credit card can slip between them. The Pyramid of Giza maintains a level foundation across 13 acres, with maximum deviation of just half an inch. These construction techniques suggest sophisticated understanding of materials, mathematics, and engineering principles supposedly unavailable to ancient builders. The conventional explanation that these were achieved through unlimited manpower and simple tools becomes increasingly untenable. Perhaps most compelling is ancient knowledge of Earth's dimensions. The Great Pyramid encodes the exact polar radius of Earth in its measurements, mathematical knowledge supposedly unavailable until modern satellite surveys. How did its builders obtain this information? Ancient sites worldwide incorporate the same geodetic knowledge, precise measurements of Earth's circumference, axial tilt, and geographic positioning. These alignments require coordinated observations across vast distances and sophisticated mathematical calculations. The explanation that all these achievements represent coincidences or lucky accidents strains credibility. The pattern suggests inherited knowledge, technical understanding preserved from an earlier, advanced culture disrupted by the Younger Dryas catastrophe. This hypothesis, that advanced knowledge existed before conventional timelines allow, remains controversial, but it aligns with geological evidence for catastrophic disruption precisely when these ancient myths place their world-ending events. The myths weren't primitive fantasies, but sophisticated encoding of actual historical events, preserved through oral tradition, symbolic systems, and monumental architecture designed to transmit crucial information across millennia. If this interpretation is correct, these myths contain vital warnings, specific information about celestial cycles and cosmic threats that directly impact human survival. Information we've dismissed as superstition may represent our ancestors' most important message. Chapter 7. Stakes Escalation. If our analysis is correct, if the Younger Dryas catastrophe was triggered by cosmic forces operating on calculable cycles, then understanding these cycles becomes critically important. Not merely for historical accuracy, but for anticipating potential future threats. Modern astronomical observations confirm our solar system moves through the galaxy in complex patterns. We orbit the galactic center every 225 to 250 million years, while oscillating through the galactic plane approximately every 30 million years. Within these larger cycles, our solar system encounters varying densities of cosmic debris. Astrophysicists have identified regions where cometary bodies concentrate, particularly the theorized Oort cloud at the outer reaches of our solar system. These concentrations aren't static. They respond to gravitational influences from passing stars, galactic tidal forces, and other cosmic factors. When disturbed, they can send showers of cometary material toward the inner solar system. Recent astronomical observations have identified a troubling pattern. The solar system appears to encounter increased cometary activity on cycles much shorter than previously recognized, cycles potentially matching the time frame of the Younger Dryas event. In 2017, astronomers discovered a stellar object designated Oumuamua, the first confirmed interstellar visitor to our solar system. Its unusual characteristics and trajectory suggested something beyond conventional understanding. More concerning, in 2019, astronomers identified the second interstellar visitor, Comet Borisov. Two such objects discovered in rapid succession suggests they may be far more common than previously believed. Our detection capabilities only recently advanced enough to notice them. These discoveries coincide with increasing recognition of previously overlooked impact craters on Earth. The Hiawatha crater beneath Greenland's ice sheet remained undetected until 2018. How many more impact sites remain undiscovered under oceans or dense vegetation? The stakes escalate when we consider Earth's current vulnerability. Modern civilization depends on interconnected systems far more fragile than we acknowledge. Electrical grids, satellite communications, just-in-time supply chains, and concentrated urban populations. A cosmic impact even fraction of the scale of the Younger Dryas event would cause unprecedented disruption to these systems. Even a regional impact could trigger global economic collapse, food shortages, and societal breakdown within weeks. More troubling is our psychological unpreparedness. Modern humans have experienced an unusually stable climate period for the past 12,000 years, the entire span of recorded history. We assume this stability is normal. Geological evidence suggests it's exceptionally rare. Our civilization has never faced a major cosmic impact. We have no cultural memory of such events, no institutional preparation, no psychological framework for understanding such threats. We've developed nuclear early warning systems, but neglected cosmic threat monitoring. The warning signs are increasing. Astronomers report growing numbers of near-Earth objects discovered annually. The Chelyabinsk meteor that exploded over Russia in 2013, injuring 1,500 people, arrived without detection, despite monitoring systems. More concerning are recent discoveries about cometary behavior. The fragmentation pattern observed in comet Shoemaker-Levy 9 before its impact with Jupiter demonstrates how a single object can create multiple impact events across vast geographic regions. This fragmentation pattern matches precisely what the Younger Dryas impact hypothesis proposes. Not a single crater, but multiple airbursts across the hemisphere. The Tunguska event of 1908 demonstrated the devastating potential of even relatively small airbursts. If the Younger Dryas was indeed triggered by Earth's passage through a field of cometary debris potentially associated with a specific region of our solar orbit, then calculating when we might encounter this region again becomes crucial. Here, ancient astronomical knowledge takes on new significance. Structures like Göbekli Tepe, Stonehenge, and the pyramids appear specifically designed to track celestial cycles, particularly patterns related to Earth's precession and ecliptic alignment. These ancient observatories weren't built for agricultural calendars alone. Their primary alignments track much longer cycles, particularly the 25,009 20-year precessional cycle that shifts our view of the stars over millennia. This precessional knowledge appears encoded in ancient myths worldwide. The Greek concept of ages, from golden to iron, tracks precessional movement through zodiacal constellations. Hindu yugas measure cosmic time through precisely calibrated cycles. Mayan calendar systems tracked multiple celestial cycles simultaneously, culminating in their long count, a 5,126-year cycle that reset in 2012. This timing places the previous reset near the beginning of historical civilization, approximately 3114 BC. Intriguingly, this date falls precisely 3 precessional months after the Younger Dryas event. Did the Mayan calendar system originate as a warning clock, tracking time until Earth's orbit would again intersect the threatening region of space? Ancient cultures worldwide share this obsession with tracking specific celestial cycles. Egyptian mythology focuses extensively on Sirius and its heliacal rising. Mesopotamian astronomy tracked Jupiter-Saturn conjunctions on 800-year cycles with extraordinary precision. These weren't abstract religious observances, but practical warning systems. Astronomical calculations designed to anticipate cosmic threats based on previous catastrophic encounters. Their sophistication suggests knowledge preserved from direct experience. The stakes escalate further when we consider the timing. If the Younger Dryas cosmic event occurred approximately 12,800 years ago, and these cycles operate on roughly 12,000-year intervals as suggested by multiple ancient calendrical systems, simple mathematics becomes disturbing. We may be approaching another such orbital crossing. The transitional period when Earth passes through regions of increased cosmic debris may have already begun. Supporting this concern, astronomers have noted increased cometary activity in recent decades. The discovery of the Taurid meteor stream, debris from a massive comet that fragmented in the inner solar system, reveals ongoing encounters with cosmic material. The Taurids are particularly significant because they originate from the breakup of a giant comet that entered the inner solar system between 20,000 and 30,000 years ago. This massive body, estimated at 100 kilometers in diameter, fragmented into the stream we encounter annually. Astronomical calculations suggest the densest part of this stream, the part containing the largest remaining fragments, intersects Earth's orbit on a cycle matching approximately the Younger Dryas timeframe. This orbital science confirms what ancient astronomers apparently knew. Perhaps most concerning, recent observations suggest we're entering a period of increased interaction with this stream. Astronomer Bill Napier's research indicates the Taurid complex contains at least 19 asteroids over 1 kilometer in diameter, any of which could cause civilization-ending impacts. NASA and other space agencies have accelerated near-Earth object detection programs in recent years. The stated goal, to identify potentially hazardous objects, acknowledges the threat while understating its immediacy and scale. The public remains largely unaware of these developments. Cosmic threats receive minimal media coverage compared to more immediate concerns. Our cognitive biases favor short-term threats over low-probability, high-consequence risks. Yet the geological record is clear. Cosmic impacts occur regularly throughout Earth's history. The question isn't if such events will happen again, but when, and whether we'll have sufficient warning to prepare or mitigate the consequences. Ancient cultures invested enormous resources in tracking celestial cycles and preserving warnings about specific astronomical alignments. They built massive stone structures oriented to track these cycles across millennia. What did they know that we've forgotten? The knowledge preserved in myth and monument suggests they recognize patterns we're only beginning to rediscover. Their warning systems tracked specific regions of the sky associated with previous catastrophes, regions we're beginning to identify through modern astronomy. If they were right, if Earth periodically encounters regions of increased cosmic danger, then we face a choice: acknowledge these ancient warnings or remain vulnerable to threats our ancestors tried desperately to help us anticipate. The structures at Göbekli Tepe, buried deliberately around 8000 BC, may represent more than an archaeological curiosity. They may be a time capsule, a message sent forward through millennia to warn of specific celestial dangers associated with calculable cycles. Similar warning systems appear in diverse cultures, from Stonehenge to Chaco Canyon, from Egyptian pyramids to Angkor Wat. All incorporate precise astronomical alignments, tracking the same celestial cycles across vast distances and cultural boundaries. What if the purpose of ancient monumental architecture wasn't religious worship, but practical survival information? What if these massive stone structures represent the most durable method available to transmit crucial warnings across millennia? The stakes couldn't be higher. If our analysis is correct, if Earth periodically encounters regions of increased cosmic danger, then we may be approaching another such crossing. The warning signs are appearing in astronomical observations and geological evidence. Modern civilization remains utterly unprepared for such an event. Our emergency planning focuses on terrorism, pandemics, and conventional natural disasters. We have no coordinated response strategy for cosmic impacts despite their civilization-ending potential. The question we must confront: did our ancestors encode specific information about these cycles? Does their obsession with certain celestial alignments and calendar dates contain practical warnings about when Earth would again face cosmic threats? If so, deciphering these ancient warning systems becomes urgently important. The knowledge preserved in stone and myth may contain specific information about threat timing, magnitude, and origin, crucial data for anticipating and potentially mitigating future impacts. The patterns are becoming clear. Ancient structures worldwide encode the same astronomical alignments, track the same celestial cycles, and preserve warnings about the same regions of the sky. This wasn't coincidence, but coordinated knowledge preservation. As we enter what may be another dangerous period in Earth's orbit, the stakes escalate beyond academic debate. Understanding what happened 12,800 years ago becomes crucial for anticipating what might happen in our immediate future. Recent near misses, like the 2019 asteroid that passed between Earth and our communication satellites with minimal warning, demonstrate our ongoing vulnerability. What would happen if we encountered not a single object, but a stream of cometary debris? The answer may be preserved in the geological record of the Younger Dryas boundary, a planetary catastrophe that nearly ended human civilization 12,800 years ago and may have reset the clock on human technological development. Are we approaching another such moment? The evidence suggests we may be. And if our ancestors' warnings are correct, we have precious little time to prepare. Chapter 8. Competing Theories. While the cosmic impact hypothesis offers a compelling explanation for the Younger Dryas event, scientific integrity demands we consider alternative theories. Several competing explanations have been proposed, each with supporting evidence and significant implications for our understanding of history. The most established alternative is the meltwater pulse theory. This proposes that as the North American ice sheets melted, enormous volumes of fresh water suddenly flooded into the Atlantic Ocean, disrupting the Gulf Stream and other ocean circulation patterns. This circulation disruption would have prevented warm tropical waters from reaching northern latitudes, plunging the northern hemisphere back into near ice age conditions. The theory elegantly explains the rapid cooling observed in climate records. Geological evidence supports aspects of this hypothesis. Researchers have identified ancient drainage channels that could have carried meltwater from glacial Lake Agassiz, an enormous ice-dammed lake larger than all the modern Great Lakes combined. Dating suggests this lake catastrophically drained around 12,900 years ago, precisely when the Younger Dryas cooling began. The estimated volume of freshwater released, over 9,500 cubic kilometers, could indeed have disrupted ocean circulation patterns. However, this theory struggles to explain several key aspects of the Younger Dryas evidence. First, it doesn't account for the simultaneous climate changes observed in the southern hemisphere, which ocean circulation disruption alone cannot explain. Second, it fails to address the extensive wildfire evidence found across continents at the Younger Dryas boundary layer, including carbon spherules, nanodiamonds, and other materials requiring extreme temperatures to form. Third, meltwater pulses don't explain the simultaneous mass extinction event that eliminated dozens of large mammal species across multiple continents. Previous meltwater events didn't trigger comparable extinction patterns. A second competing theory involves volcanic activity. Several major volcanic eruptions occurring in close sequence could theoretically inject enough sulfur dioxide and ash into the atmosphere to trigger global cooling through reduced solar radiation. Volcanic materials have indeed been found in some Younger Dryas boundary layers. The Lake Sea eruption in Germany occurred around 12,900 years ago, coinciding with the onset of the Younger Dryas cooling period. However, the volcanic hypothesis faces substantial challenges. While powerful, even the largest known eruptions produce cooling effects lasting only a few years, not the 1,200-year duration of the Younger Dryas period. Additionally, volcanic eruptions don't produce the specific materials found at the Younger Dryas boundary, particularly nanodiamonds, magnetic spherules with extraterrestrial isotope ratios, and platinum anomalies, consistent with cosmic rather than terrestrial sources. A third explanation involves solar minimum conditions. Variations in solar output follow several overlapping cycles. A prolonged solar minimum, a period of reduced solar activity, could potentially trigger cooling through reduced radiation reaching Earth. Evidence for this comes from beryllium-10 isotope measurements in ice cores, which indicate changes in cosmic ray flux associated with solar activity. Some data suggests a solar minimum occurred around the Younger Dryas onset. However, like the volcanic hypothesis, solar minimums typically produce climate effects lasting decades, not millennia. And solar variation alone cannot explain the presence of impact-related materials or the abruptness of both the cooling onset and termination. A fourth theory proposes self-sustaining climate feedback loops. Once cooling began, through whatever initial trigger, expanded ice coverage increased Earth's albedo, reflectivity, reducing solar heat absorption and accelerating cooling in a self-reinforcing cycle. This feedback mechanism likely contributed to the Younger Dryas duration, but fails to explain the initial trigger or the extraordinary abruptness of both onset and termination. Climate feedback systems typically produce gradual changes, not the sudden shifts observed. Each competing theory explains certain aspects of the evidence, but leaves other significant questions unanswered. This has led some researchers to propose hybrid models incorporating multiple mechanisms, an initial cosmic impact, followed by meltwater pulses and climate feedbacks. This integrated approach resolves many contradictions. A cosmic impact could have destabilized remaining ice sheets, triggering meltwater release. The combined environmental effects would have initiated climate feedback cycles, extending the cooling period. The most compelling evidence against the cosmic impact hypothesis comes from critics who note the absence of a single large impact crater dating precisely to 12,800 years ago. Traditional impact models suggest a crater should be evident. However, this criticism reflects outdated understanding of cosmic impacts. Modern research reveals that cometary objects frequently fragment in Earth's atmosphere, creating multiple airbursts rather than a single crater-forming impact. The 2013 Chelyabinsk meteor demonstrated this pattern on a small scale, exploding in the atmosphere with the force of 30 Hiroshima bombs without reaching the ground intact. The 1908 Tunguska event similarly flattened 80 million trees without forming a significant crater. Scale this phenomenon to a larger fragmenting comet, and the Younger Dryas impact hypothesis becomes entirely plausible without requiring a single large crater. Multiple smaller impacts and airbursts across the hemisphere would leave precisely the evidence pattern we observe. The 1994 Shoemaker-Levy 9 comet impact with Jupiter demonstrated how a single object can fragment into multiple impactors. The string of pearls effect created 21 separate impact events across Jupiter's surface over 6 days. If Earth encountered a similar fragmented object, the resulting pattern would match the distributed evidence found at the Younger Dryas boundary, from Greenland to Venezuela, from Europe to the Middle East. Recent discoveries strengthen this multiple impact model. The Hiawatha crater in Greenland, while still being precisely dated, shows characteristics consistent with the Younger Dryas timeframe. Additional suspected impact structures have been identified in the Carolinas and Middle East. Perhaps most significantly, critics initially insisted that without a crater, no impact could have occurred. The discovery of the Hiawatha crater fundamentally undermines this objection, demonstrating that impact evidence may remain undiscovered, particularly beneath ice sheets or ocean waters. The scientific debate continues, with researchers on both sides presenting evidence and counter-evidence. This healthy skepticism drives further investigation and refines our understanding of what truly happened at this critical moment in human history. What remains undeniable is that something extraordinary occurred 12,800 years ago, something that dramatically altered Earth's climate, triggered mass extinctions, and potentially reset the course of human civilization. The pattern of evidence, while subject to interpretation, cannot be ignored. Chapter 9. New Science and Paradoxes. Recent scientific advances have transformed our understanding of the Younger Dryas event. In 2022, researchers published findings from comprehensive analysis of ice cores spanning this period, revealing previously undetected platinum anomalies at precisely the Younger Dryas boundary. Platinum is rare in Earth's crust, but abundant in asteroids and comets. Finding platinum spikes in ice cores from Greenland to Antarctica provides compelling evidence for a global-scale cosmic event, exactly as the impact hypothesis predicts. Similarly, advanced microscopy techniques have identified previously overlooked evidence in boundary samples. High-resolution electron microscopy reveals nanoscale features in carbon spherules that can only form under the extreme conditions of cosmic impacts. Perhaps most significant is the development of improved dating techniques. Accelerator mass spectrometry now provides carbon dating precision within decades rather than centuries, allowing researchers to precisely correlate events across continents with unprecedented accuracy. These refined dating methods confirm that climate changes, extinction events, and the appearance of impact-related materials occurred simultaneously worldwide, a synchronicity difficult to explain through gradual or regional mechanisms. Genomic studies add another compelling dimension. Analysis of ancient DNA reveals population bottlenecks in multiple species, including humans, coinciding exactly with the Younger Dryas boundary. These genetic choke points indicate sudden, dramatic population reductions. Human mitochondrial DNA suggests a significant population collapse occurred approximately 13,000 years ago, precisely when the Younger Dryas began. Similar patterns appear in the genomes of surviving North American mammals, indicating a common environmental stress. This genetic evidence is particularly significant because it provides an independent confirmation of catastrophic environmental change, one not subject to the same interpretive debates as geological or archaeological data. Advanced computer modeling of comet and asteroid dynamics has identified a previously unrecognized threat pattern. The Taurid meteor stream, debris from a massive comet that fragmented in the inner solar system, intersects Earth's orbit on cyclical timescales. Astronomical calculations suggest this stream contains larger fragments concentrated in specific regions. Earth passes through these denser regions on predictable cycles that align disturbingly well with the timing of the Younger Dryas event. Further confirmation comes from chemical analysis of Greenland ice cores, which recently identified unique molecular compounds only found in cometary materials. These compounds appear precisely at the Younger Dryas boundary, providing a direct chemical fingerprint of extraterrestrial material. Perhaps most unexpected is evidence from marine geology. Deep-sea core samples reveal an abrupt shift in ocean circulation patterns exactly 12,800 years ago. A shift too rapid to explain through gradual climate change. These marine cores also contain microscopic magnetic spherules with isotope ratios matching extraterrestrial materials rather than terrestrial volcanic sources. The global distribution of these spherules indicates an atmosphere-wide dispersal event. New paradoxes emerge from these findings. If the Younger Dryas was triggered by a cosmic impact, why did the cold period last 1 to 200 years? Impact winter effects typically last decades, not millennia. This duration suggests additional mechanisms were involved. The answer may lie in climate feedback systems. Once triggered by the initial catastrophe, self-reinforcing feedback loops could have maintained cold conditions until reaching a threshold that triggered equally rapid warming. Another paradox: if advanced human cultures existed before the Younger Dryas, why is physical evidence so limited? The answer may be devastatingly simple. Rising sea levels have submerged the most likely habitation sites. Humans naturally settle along coastlines and river valleys. With sea levels 300–400 feet lower during the last ice age, prime habitation zones would have been on coastal shelves now deep underwater. Our archaeological record may be literally submerged. This hypothesis gains support from underwater discoveries. Structures like those at Yonaguni, Japan, and India's Gulf of Cambay show characteristics of intentional construction, but lie beneath 100+ feet of water, depths reached only after the Younger Dryas meltwater release. Perhaps the greatest paradox involves ancient knowledge preservation. If advanced astronomical understanding existed before the Younger Dryas, how was this knowledge transmitted through a civilization-ending catastrophe? The answer reveals something profound about human ingenuity. New analysis of ancient sites reveals they functioned as durable information storage systems, using stone architecture and precise alignments to encode complex astronomical knowledge. These structures were designed specifically to survive catastrophic events. The recurrence of specific mathematical constants across these sites, including pi, phi, and precise measurements of Earth's dimensions, suggests intentional encoding rather than coincidence. These were knowledge preservation systems built to endure millennia. The paradox resolves when we recognize the purpose behind megalithic construction. These weren't merely ceremonial structures, but functional devices, astronomical computers built in stone, designed to preserve crucial knowledge through catastrophe. This explains their global distribution and common features, despite apparent cultural isolation. The knowledge wasn't independently discovered, but deliberately preserved and transmitted by survivors of the Younger Dryas event, a knowledge preservation network spanning continents. New dating of these structures reveals another pattern. They appear in sequence following the Younger Dryas, beginning with Göbekli Tepe, 9600 BC, followed by similar constructions across the Mediterranean, Western Europe, and eventually the Americas and Pacific. This sequential appearance suggests knowledge transfer rather than independent invention. Survivors of the catastrophe gradually re-establishing a global knowledge network, with each new construction encoding the same astronomical information in locally adapted forms. Perhaps the most profound paradox involves human psychological response. If our ancestors experienced such devastating catastrophes, why don't our cultural traditions explicitly warn about cosmic threats? Why was this knowledge encoded in architecture rather than directly stated? The answer may reflect understanding of human psychology. Direct warnings fade over generations or become dismissed as myths. Encoding warnings in functional astronomical observatories ensured the knowledge remained practical and culturally relevant across millennia. This approach, embedding crucial information in durable functional systems rather than explicit warnings, demonstrates sophisticated understanding of information transmission across deep time. Our ancestors were solving a complex communication problem across millennia. New paradoxes emerge from ancient textual traditions. Sumerian, Egyptian, and Vedic texts contain sophisticated astronomical calculations alongside what appear to be mythological narratives. These weren't separate categories for ancient knowledge keepers, but integrated systems. The myths provided memorable frameworks for preserving complex information. Mathematical knowledge was embedded within dramatic narratives to ensure transmission. Gods and heroes represented celestial bodies and their movements. Divine battles encoded cosmic events. This integration of knowledge explains why ancient cultures invested such extraordinary resources in astronomical observation. They weren't engaged in abstract religious worship, but practical threat monitoring, tracking celestial cycles associated with previous catastrophes. The central paradox resolves: ancient people weren't primitive beings who gradually stumbled towards civilization. They were cognitively modern humans responding to catastrophic disruption with sophisticated knowledge preservation strategies. Strategies we've only recently begun to recognize. Chapter 10. The Big Reveal. The evidence converges toward an inescapable conclusion. Approximately 12,800 years ago, Earth encountered a fragmenting comet that triggered a cascading sequence of environmental catastrophes, nearly ending human civilization and forcing a traumatic restart. This wasn't a minor climate fluctuation, but a civilization-ending event that left permanent scars in both Earth's geology and humanity's collective memory. The evidence appears across disciplines, from ice core chemistry to ancient architectural alignments. Most significantly, this event wasn't random. It appears connected to cyclic movements of our solar system through regions of the galaxy containing higher concentrations of cometary debris, cycles that ancient astronomers recognized and encoded in stone monuments worldwide. This represents the true revelation. Our ancestors weren't primitive star worshippers, but practical astronomers who recognized genuine cosmic threats. Their monumental architecture and mathematical knowledge served specific survival purposes, tracking cycles of existential danger. Their warning system was ingenious. Rather than relying on written records that degrade or become misinterpreted, they created functional observatories that maintained cultural relevance across millennia. Stonehenge wasn't ceremonial, it was computational. These structures encoded precise measurements reflecting Earth's dimensions, astronomical cycles, and mathematical constants. This wasn't arbitrary, but deliberate knowledge preservation, creating self-contained systems that could reconstruct crucial information even if supporting context was lost. The knowledge preserved wasn't religious but practical, tracking the 25,920-year precessional cycle, monitoring specific celestial regions associated with previous impacts, and maintaining mathematical constants necessary for astronomical prediction. This explains the otherwise baffling similarities between isolated megalithic sites worldwide, from Göbekli Tepe to Stonehenge, from Easter Island to Chaco Canyon. These weren't independent developments, but nodes in a global knowledge preservation network. The survivors of the Younger Dryas catastrophe understood something crucial. Civilization might collapse again. Information vital for long-term human survival needed preservation in forms that could endure through dark ages and cultural discontinuities. Their solution was elegant: encode this knowledge in massive stone structures serving multiple purposes: astronomical observatories, calendars, and teaching devices that would maintain cultural significance regardless of linguistic or religious changes. The big reveal isn't just what happened 12,800 years ago, but what it means for our understanding of human history. The linear progression from primitive to advanced must be replaced with a more complex pattern of advance, catastrophe, and recovery. This cyclic pattern appears consistently in ancient traditions worldwide, from Hindu yugas to Mayan world ages, from Hopi prophecies to Norse cycles of destruction and renewal. These weren't primitive myths, but sophisticated historical models preserving memories of actual collapse. Most critically, this understanding transforms how we interpret ancient astronomical knowledge. Their precise tracking of celestial cycles wasn't superstition, but practical threat monitoring, maintaining awareness of cycles associated with previous catastrophes. The recurring symbolism of celestial serpents or dragons, from Chinese astronomy to Mesoamerican carvings, from Norse mythology to Hindu traditions, represented actual cometary encounters. These weren't arbitrary symbols, but observational records of cosmic threats. This revelation reframes ancient obsessions with specific astronomical alignments. Sites oriented to track the Taurid meteor stream, debris from the very comet that likely triggered the Younger Dryas event, represent practical warning systems monitoring known threats. Modern astronomical research confirms this ancient understanding. The Taurid complex contains substantial debris, including objects large enough to cause regional or global catastrophes. Earth passes through denser regions of this stream on calculable cycles. These cycles align disturbingly well with evidence for previous impact events in Earth's geological record, including one approximately 12,800 years ago. Our ancestors recognized this pattern and invested enormous resources in tracking it. This explains the otherwise puzzling precision of ancient calendrical systems. The Mayan long count, measuring 5,126 years, tracks approximately 1/5 of the precessional cycle. Combined with their other calendars, it created a sophisticated cosmic warning system. The big reveal extends beyond ancient knowledge to future implications. If these cosmic cycles are real, if Earth periodically encounters regions of increased impact threat, then understanding these cycles becomes crucial for anticipating future dangers. Astronomical calculations suggest Earth is currently entering another such period of increased risk. The orbital path that intersects the Taurid stream's densest regions appears to be approaching another crossing, precisely as ancient warning systems predicted. This doesn't guarantee catastrophe, but suggests increased vigilance is warranted. The concentrated regions of the Taurid stream contain numerous objects large enough to cause significant damage, from regional disasters to civilization-threatening impacts. Modern astronomical observations confirm unusual activity. Since 2015, astronomers have recorded increased fireball activity during Taurid meteor showers, indicating Earth is passing through regions containing larger debris fragments. These observations vindicate ancient astronomical concerns. The specific celestial regions they monitored with such precision do indeed present measurable impact threats operating on precisely the cycles their monumental architecture was designed to track. The implications transform our understanding of both past and future. Human civilization likely didn't begin 5,000 years ago, but was reset by cosmic catastrophe approximately 12,800 years ago. The knowledge preserved through that bottleneck represented crucial survival information. This explains the sudden appearance of advanced astronomical and mathematical understanding in early historical civilizations. This knowledge wasn't developed from scratch, but preserved from earlier, more advanced predecessors who recognized its survival value. The revelation demands we reconsider ancient warnings with new seriousness. The precise astronomical alignments at sites worldwide weren't ceremonial, but functional, designed to track specific celestial cycles associated with measurable cosmic threats. Most importantly, this understanding may prove crucial for our future. If Earth is indeed entering another period of increased cosmic vulnerability, as both ancient knowledge systems and modern astronomy suggest, then preparing for potential impacts becomes a civilizational priority. Unlike our ancestors, we possess technologies capable of detecting and potentially deflecting threatening objects, but we've invested minimal resources in planetary defense compared to other priorities. a dangerous oversight if the cyclic threat model is correct. The big reveal isn't that history needs rewriting, though it does. The revelation is that our ancestors encoded specific warnings about recurring cosmic threats, warnings preserved at enormous effort across millennia that we've systematically misinterpreted as mere ceremonial structures. Their message, encoded in stone architecture precisely aligned to astronomical cycles, was clear. Cosmic catastrophes occur on predictable timescales. Civilization's survival requires maintaining awareness of these cycles and preparing for inevitable encounters. We stand at a pivotal moment, possessing both the scientific understanding to recognize these patterns and the technological capability to address them. The question is whether we'll heed the warning our ancestors worked so diligently to preserve across 12,800 years. As we conclude our investigation, we return to where we began, standing at the threshold between worlds, witnessing Earth as it existed 12,800 years ago, when humanity faced existential crisis. The evidence tells a remarkable story. Our civilization isn't the apex of human achievement, but the most recent iteration in a cycle of advance and catastrophe. What we call the beginning of history may actually mark the recovery from cosmic catastrophe. This understanding transforms how we perceive both our past and our future. The megalithic structures worldwide weren't primitive attempts at astronomical observation, but sophisticated warning systems designed by people who understood cosmic cycles through direct experience. Their message reaches across millennia. The threats they faced will return on calculable timescales. Their monumental architecture encodes both warning and the knowledge necessary for prediction, a gift from ancestors who survived catastrophe and preserved crucial information for future generations. The question we now face is whether we'll recognize this gift for what it is. Will we dismiss ancient knowledge as primitive superstition, or will we integrate it with modern science to better understand our cosmic vulnerabilities? Perhaps our greatest advantage is that we stand at an unprecedented moment, possessing both the scientific understanding to decode ancient warnings and the technological capability to address the threats they describe. For the first time, we can both predict and potentially prevent cosmic catastrophe. The journey through our true history reveals something profound about human resilience. Despite facing civilization-ending catastrophe, our ancestors preserved crucial knowledge and rebuilt. Their legacy isn't just in stone monuments, but in the warning they encode. As we face uncertain cosmic futures, remember this: you are part of an unbroken human story, stretching back before recorded history, a story of catastrophe, resilience, and renewal. Our ancestors faced the stars with both wonder and vigilance. Perhaps we should do the same. If you found this exploration of our hidden past meaningful, subscribe for future journeys through the mysteries of human history and cosmic connection. Together, we'll continue decoding the messages our ancestors preserved at such cost, messages that may prove crucial for our shared future.